Okay, good morning, ladies and gentlemen. It's my pleasure to be here to give a talk about the response of phytoplankton to ocean dust depositions in China coastal seas. I think you may be quite familiar with the Sahara dust here, but we have an ocean dust. It's a different system, but the impacts may be quite similar. For myself, this is my scientific interest is about atmospheric depositions of dust and nitrogen and the bioresponse to atmospheric input and biochemical modeling of phytoplankton ecosystems and some subsurface chlorophyll maximum in stratified oceans, and then lastly the long-range transport of air pollutants from the oceans maybe to China, to other countries. Okay, this is a scale map of the solar surface ocean load study. So this map told us this is atmospheric emissions and where we transport a long distance to the oceans. So this is the wet and dry deposition to the oceans, and then there are some response from the oceans, especially response to the nutrients. For example, nitrogen, phosphorus, iron, and carbon, something else. This is a map of principal dust systems. This is the first one is Sahara dust. So in summer and in winter, they are transported in different directions and impact for different areas. Here, so here is Mediterranean Sea and Atlantic Ocean. Sometimes they have some impact here. For the atmospheric ocean dust systems, is mostly come from the Taklamakan Desert and the Quebeq Desert, and the transport to the northeast. Normally, it's an impact for quite a broad areas, even bigger than these areas. But this emission amount is just 1/5 of this sulfur dust. This figure told us the land surface property will be changed and dust viability will be changed. And then this is the loading of the atmospheric dust. Of course, include some nutrients and some metals. Based on this map, then we will be some estimation of iron supply to the oceans and some response from marine productivity, and then have some impact to the oceans, to the climate and oceans. For the Pacific dust studies, quite an earlier studied by the Bob Deuce, quite big head in this field. So this paper just published many years ago, and then there are some another papers to show the transport of dust from the Taklamakan Desert to Japan and to the Pacific Ocean. And some effect that dust is one of the most abundant aerosols in Earth's atmosphere, comprising of about 75% of the global aerosol mass loading. So, Asian dust sources, including the Taklamakan Desert, Quebeq Desert, and the Chinese Lesis Plateau, represent 1/4 of the global dust emissions. So it's compared to the Sahara dust, it's quite a little. And the Japan scientists estimated that 6 to 12 million tons of ocean dust is transported annually to the central North Pacific. And then in the recent years, we find the blooms in various locations of the Pacific Ocean were attributed to ocean dust depositions. This is the example here in the Pacific Ocean. This is in 2001. This is the calendar days. Around these days, there are some aerosol index increase. That means there are dust storm. And maybe 2 weeks later here, there are a peak of chlorophyll. So that means maybe the aerosol depositions will have some contributions to the chlorofluoride concentration. Also, we have some other studies in different areas of the, for example, here and here, they have some studies to show the Asian dust exactly have some relations with chlorofluoride blooms. For the Asian dust, we have 4 major sources. This one is the Taklamakan Desert. This is the Quebeq Desert. This is the Hershey Cradle. This is the India continental. So this is the 4 sources, main sources. This is the symbols to show from this year to this year, there are the frequency of dust storms. So that you can show even in the South, the Korea and Japan, there are some impact, have some impact by the Asian dust. For the Asian dust, annually variations just like this. This is dust break frequencies. Normally in March, April, and May. So normally it's this is the peak in April, and just this is the strong wind. That means the wind velocity will have some impact of the dust outbreak frequencies. And here, this is we call it African dust, sand dust. They have this peak, but for the Asian dust, here the peak is quite weak. This is the China coastal seas. For the China coastal seas, the sources of dust normally is from the Mongolia and Inner Mongolia. For the west of the Mongolia, the middle and the east. So not from the Taklamakan Desert. This is the example. Qingdao city is here. It's our hometown, our university. Look there. This is Jeju Island. It's a Korea island here. We have some estimations from 2001 and 2007. This is in 7 years. This is the numbers of dust in Qingdao city, and these numbers of dust in Jeju Island. For example, in 2001, totally this and this, about 45% will come to Jeju Island, will come from the Qingdao city. So totally in the 7 years, about over 60% will Asian dust will come from the Qingdao city. This is our estimations of dust deposition. So from this figure, you can show the red one is the wet, the blue one is dry. So what? Yeah, should be different ammonia and nitrate. So this is quite clear. For the wet deposition, is quite important compared to the dry one. And this we have estimated some flux of DON. Normally, the DON is maybe contribute to a great amount to the total nitrogen. This figure to us, this is the satellite image. This is the chlorofluoride concentration in the oceans. So this is before the dust storm on April 7th, just like this. Is the chlorofluoride concentration is quite low. And then the concentration increase. This is after dust storm on April 7th. And another dust storm, April 17th. And another one is April 23rd. So normally in the spring times, the dust will come one by one. Here we have also do some statistical studies. This is the correlation of Asian dust with the chlorofluoride and the production in the Yellow Sea. Here, this Qingdao city is here. The Yellow Sea is from just around the area. So during this period of time, 10 years, this figure told us this is the chlorofluoride concentration. This is the primary production. So it's quite clear. This is dust frequency. So from 1990s to 2001, and also in 2006, have a quite a lot dust frequency, and then the production or chloride concentration is increased. And this figure told us the bloom frequency is just in the sea. So this the every days with AI aerosol index. That means if aerosol index is bigger than 2, we think they could be impacted by dust storms. So the two lines is quite consistent to each other. Quite interestingly, here this is the sources, the frequencies of dust in the source areas. So here is Taklamakan Desert. There's a lot of dust storms here, and there's the Quebeq Desert along the Mongolia border. Yeah. So if we divided the Pacific Ocean into several parts, for example, here is the China coastal areas, oceans. This is the subarctic North Pacific, the North Pacific subtropical gyre, and the West Europe Equatorial Pacific, the Eastern Equatorial Pacific. This figure told us where the dust come from for oceans. For example, this is the coastal seas. That means for these areas, most of the dust to impact these areas come from this here. This is in Mongolia and the Mongolian borders. And for the Eastern Japan Sea, it's here. So a lot of sources will have impact to these areas. But for North Pacific subtropical gyre, for these areas, only the dust from Inner Mongolia and maybe these areas have impact to these areas. So different areas have different impact to the area of the ocean. A bloom in the Yellow Sea 2007 was observed during the cruise. This is before the blooms and during the blooms, so the color changed of the surface ocean. This is in 2007. We have a cruise. A bloom was observed in the South Yellow Sea on these days, just several days after a dust event in a week. We have a bloom here. This is the stations of we have blooms observed on these stations, so maybe this is quite a big areas. This is satellite data of chloride. This is at the end of March, April, the 2, 3rd, 4th, 6th, and 9th. So for the April 3rd, April 4th, the chloride is increased. For these areas, so it's quite clearly to the 4th, 5th, and 6th, the chloride and the mean chloride and the maximum chloride is increased compared to the normal width. This is the aerosol index. It shows the dust come and how the dust impact. At the end of March, it's just here, and then it's moved to this here. And on April 1, they have a rainfall, so the wet deposition come to the ocean. And then later, April 2nd, they move to the east. So we also have estimated this TSP, phosphorus, iron, and this nitrogen concentrations of the ocean. So it's quite clearly for the TSP concentrations increase much. Do we know how about the TSP here? Normally, maybe 30, less than 30, sometimes 20, 50, I think so. Here is just 2,000, so quite heavy. And for iron, there are some depositions. For the particles and ammonium nitrate in different sizes of aerosols, it shows this is a solid one is with the impact of ash and dust. So normally they come to the big size. And for the ammonium, always on the small size. This is the concentrations and the solubility of iron, and soluble iron. So for the dust event, during the dust event, the iron and the soluble iron is increased, but solubility not so high. In general, there are at the end of March there are high inputs of nitrogen, phosphorus, and iron, and then 1 week later there are a big peak of chloride. So the chloride reached about 10 microgram cubic meter. So that means there will be a bloom here, and this high concentration keeps a week till April 4th or 5th, about 4 microgram per cubic meters. And we also estimate how much was the estimation of the TI nitrogen and the dust. So we have a estimation dust fluxes about this, about tens cars per square kilometers. For this dust storm, for aluminum in the surface ocean increased for 2,200. Iron, we have know the background values. We just estimate maybe increased just like this. For DIN, it's increased 25% to 200%, and the DIP from 2% to 50%, and the chloride A maximum is the 800%. So that means it's quite clearly it's a bloom. Summary for this dust event followed with a rainfall about this, very high TSP up to 2,000, so it's maybe 200 times higher in the low atmosphere of the Yellow Sea. What color changed algae bloom for 5 days after the dust events. This is the increase of chloride A. Here I want to say there are obvious impact of atmospheric inputs on coastal oceans. Normally, people think that dust maybe just have an impact on the Pacific Ocean, on the low nutrient areas. But here we think the dust, heavy dust, will have obvious impact on the coastal oceans. To understand the mechanism of the response of a biter to the dust input, we have some incubation experiment on board. So this is the research vessel. So we have a different treatment for the different bottles. So this is the dust A, the small amount, and a big amount. This is nitrogen, phosphorus, iron, and the nitrogen and rainwater. So we collected the surface water here, and then the research vessel will go this way. And the duration of our experiment about 2 weeks. So this is some ideas. This is chloride, this is ST during this experiment, and this is the PAR for the experiment. This is our background of this experiment. So the nitrogen is just like this, the silicate, the phosphate, chloride. So it's in the middle of HNRC and the LNRC. So here is nitrogen, the ratio of nitrogen and phosphorus is 10. And nitrogen, the ratio of nitrogen and silicate is 10 to 24. So from this nutrient variations show clearly in the first stage of the experiment, about 10 days, will decrease obviously, and then keep quite low values. This is with different treatment, the dust, this is nitrogen, phosphorus, iron. So especially for nitrogen, here is quite increased, so high. This is dust, so the dust, the rainwater and dust will be increased. So that means here maybe the nitrogen limited areas. So nitrogen input will be important to this area. We also do some measurement of the different size of chloride. So this is the bigger than 20 micrometer, and this is the medium and the small size. This is the duration days, experiment days. From this, we can see in the first several days, the medium size keep quite low, the contribution. But later, the medium size phytoplankton will be dominate this system. We also have a estimate of the conversion efficiency index of nitrogen. From this figure, it's quite clearly for the phosphorus, dust B, and iron input will have a quite high conversion efficiency. But for the rainwater, it's quite low. We think maybe some metals have a negative impact on the phytoplankton growth. This is a summary for the Asian dust blooms. And in the future, we are still working on these areas. So these areas should be the dust sources areas. And in the coastal areas, they have high concentrations of nutrient. And these have quite a low nutrient. And this is the high nutrient, low profile areas. They also, both these three areas will have impact by the Asian dust. So this is the concentrations of nitrogen, so it's quite different areas. We will still do some onboard measurement and incubations. So we will do that in the shelf seas in the LNRC, West Pacific, and in the laboratory. We will have model simulations, for example, MPZD box model, 3D biophysical models. We still have a SOLAS task team, ADOS, Asian dust, and ocean ecosystem, and the SOLAS framework. This is our some onboard incubations in the area still in the Yellow Sea. This is in this environment, the Daniel flat may be bigger than 13%. And the atom is quite small contributions. In this case, it's almost the phosphorus limited scenario. We still have to do some experiment on this. It's the East China Sea and in South China Sea. And in the last year, we have to do some experiment in the Pacific Ocean. This is the Nangos, 3 Nangos is the incubation water. We collect the incubation water here. And the station this year, from March to May, we have some cross from here and come here and go back. So for this triangle areas, we have the surface ocean, surface water, and have do some incubation experiment. But the results are still on the analysis. Oh, this is a group photo for our cross paper. This is our research, Donghong 2 research vessel. Okay, it's my talk.